Okay, so for this video, we'll be dealing with concepts on potential and kinetic energy, relate the work done by a constant force to the change in kinetic energy of a system, apply the work energy theorem to obtain quantitative and qualitative conclusions regarding the work done, initial and final velocities, mass, and kinetic energy of a system. So some of these topics were already discussed in your junior high school, but the questions are a little bit more tricky compared with, of course, the junior high school level. At the same time, we need to exert a little bit of common sense and patience para ma-solve yung mga problems na meron tayo. But before that, let's first define kinetic and potential energy. Remember that kinetic energy is associated with objects that are moving. So technically, it's energy in motion, while your potential energy is associated with objects that are at rest or energy in waiting. Technically, yung term na at rest is no longer used. If we're strictly speaking about potential energy, there are different types of potential energy, or gravitational potential energy, and then elastic potential energy. But we are focusing now on gravitational potential energy. So both of them also have their own formulas. You have kinetic energy is 1 half mv squared. Gravitational potential energy is related with mass, gravity, and height. So if we're going to try to what do you call this? Understand the relationship between mass, velocity, height in terms of GPE and KE, let's try to make the mass constant. So, halimbawa, constant yung mass natin. In terms of kinetic energy, the faster the object is in terms of velocity, of course, the higher the kinetic energy is. What we're trying to say here is that we want to get a relationship between velocity and kinetic energy. So, pag mas mabilis, mas mataas yung kinetic energy. Saying that the mass is constant. Okay, in this case, para lang magkaroon ng relationship. In GPE naman, let's say that the mass is constant and of course your gravity depends on the place that you are in. So, halimbawa, Earth, if you are on a higher level, for example, comparing sa Bilardo first floor sa Bilardo fifth floor, mas mataas yung GPE because mas mataas yung height nung tao na nasa fifth floor compared sa nasa first floor. This is again telling you that the velocity and height is closely related, not really closely, but is related with kinetic energy and GPE. If we're going to really not consider the mass or consider the mass as constant. Okay, so I hope this one is clear. So, let's try to solve problems para mas madaling maintindihan natin yung GPA and KE. Okay, so which has greater kinetic energy, a 2 kilogram mass moving 3 meters per second, or 1 kilogram mass moving at 6 meters per second. So here you have different masses, but they also are traveling at different speeds. So let's see, kung mas mabigat ba and medyo mabagal, mas mataas yung kinetic energy, or pag mas magaan at mabilis, mataas yung kinetic energy. So this is just an example of what we are trying to say here, that if we make the mass constant, obviously, mas mabilis ka, mas mataas yung kinetic energy mo. Here, however, the masses are different. 2 and then 3, and also their velocities are different. So, what we're going to do here is check kung sino yung mas mataas yung kinetic energy. So, KE1 tayo. Ito naman ay KE2. So, this is 1 half mv squared. This is also 1 half mv squared. So, dun sa mass ng isa, meron tayong 2 kilograms, while yung velocity naman ay 3 meters per second squared. Dito naman, 1 half times 1 kilogram, the velocity is 6 meters per second squared. So, pag tinignan mo pa lang, medyo mas lamang na kaagad yung 6 meters per second. But let's try to evaluate. You'll be getting 9 joules here in terms of kinetic energy, 1. And then for kinetic energy, 2. This is also 9, not 9. This is 18 joules. Sir, paano mo nalaman na joules yung unit ng kinetic energy? So, kung titingnan po natin, this is kilogram. Ito naman ay meter per second squared. Actually, kilogram meter squared per second squared kasi naka-square tayo. Remember that kilogram meter per second squared ay isang newton. Meron ka pang tirang isang meter dito. So, Newton meter is just joule. Okay? So, that's why I've indicated that the unit is in joules. This is also related with the video that you'll be seeing later, or the explanation why work and energy are related with each other, aside from they have the same units. Okay? So, obviously, mas mataas yung KE2 compared with KE1. Next, a 75-kilogram child climbs a 6-meter ladder. What is the potential energy of the child with respect to the ground, assuming that this is in the earth? Kasi yun ang may common na gravity na alam natin. Mass is 75 kilograms. The height is 6 meters. 6 meters. So you have GPE is equal to mgh. You have 75 kilograms times the gravity is 9.8 meters per second squared. And then the height is 6 meters. Ayan, nakita nyo to, kilogram meter per second squared ay Newton times meter. So, joules pa rin siya. So, multiplying everything, you'll be having 4,410 for your potential energy or GPE. Newton meter or joules. So, very easy. So, this is just to refresh you of how to solve your kinetic energy and your potential energy. Next problem, a car of a mass 1,000 kilogram traveling at 30 meters per second has its speed reduced to 10 meters per second by constant braking force over a distance of 75 meters. What is the initial kinetic energy and what is the final kinetic energy? So here it's very important again to indicate the given. The mass is 1,000 kilograms. The initial velocity is 30 meters per second. Na-reduce daw siya dahil nag-brake ka. So this is 10 meters per second. Yun yung magiging final velocity. And then the distance is 75 meters. So, kung titingnan mo po, obviously yung 75 meters ay pampagulo lang siya. So, i-half natin to para mas madali. KE initial, because that's the first problem. And then KE final. So, dito na lang sa baba. 1/2, the mass is 1,000. I won't be putting the units anymore because you know that already. You should know that by now. 30 squared. Okay, so you'll be getting here 450,000 joules. Or if we're going to use engineering notation or scientific notation na lang, 4.5 times 10 raised to 5 joules. So here naman, you have 1/2, again, times 1,000 times 10 meters per second squared. And the final becomes 50,000 joules or 5.0 times 10 raised to 4 joules. Okay, so obviously, since medyo mas mabagal na yung isa, the final velocity of the car is lower compared to the initial. Obviously, the kinetic energy will be lower compared with the previous one. Okay, so very easy. Last, I think this is the last problem. What is the potential energy of the 10 kilogram mass above the surface of the earth and the bottom of a vertical mine shaft? So for the first one, almost the same lang sila. But if you try to observe 100 meters above, this is 100 meters below the surface of the earth. So if you're going to solve, mass is equal to 10 kilogram. The height is 100 meters kasi above. Dito naman, mass is 10 kilogram and then the height is 100 meters below. This becomes, since it's below, we can indicate yung negative na kasi nasa may baba na po siya. Okay? But in the case of this one, kasi this is just for, what do you call this? Para lang mas ma-differentiate natin yung GPE ng dalawa. So, GPE here, if we're going to just multiply mgh, lalabas po dito ay 9,800 joules kasi above. GPE here, since below, becomes negative 9,800 joules. Okay? Because yung height mo nga ay technically yung height mo ay nasa baba. So, hindi ka na masyadong affected by the gravity. Okay? So, yeah. That's it. So, again, what is work? Basically, work is a transfer of energy, while energy is the ability to do work. So, how is work and energy related? So, for the next videos, which will be discussed by Ma'am Mars, she will be discussing to you how work and energy are related with each other, and I will be showing you the problem solving for the work energy theorem. Okay?